In 2022, researchers re-examined a skeleton pulled from a cave in the Dinaric Alps in the 1950s. The bones were thick, the brow ridge pronounced, the inner ear structure unmistakably Neanderthal. When they ran modern radiocarbon tests, the date came back 10,200 years ago. Not 40,000, 10,000. That's not the Ice Age, that's the age of agriculture, of permanent settlements, of the first monumental rituals. Neanderthals were supposed to be extinct for 30,000 years by that point. So, either the date is wrong, the bones are wrong, or the human story is. A new skeletal analysis, combining high-resolution radiocarbon dating, microstructural bone chemistry, and revised stratigraphic models, is forcing researchers to confront an uncomfortable possibility. What if Neanderthals did not vanish when we thought they did? What if small populations endured, isolated, overlooked, and biologically distinct, until as recently as 10,000 years ago? This is not a story of sudden discovery, but of evidence long ignored, misdated, or misunderstood. And it is reopening one of the most consequential questions in human evolution. How alone were we really at the dawn of civilization? In 1856, quarry workers in Germany's Neander Valley were blasting limestone when they uncovered something strange. Thick bones, a skull capped by a heavy brow ridge. The first Neanderthal. From the beginning, they were framed as evolutionary dead ends. Stocky, primitive, intellectually inferior. That image has collapsed over time. We now know Neanderthals buried their dead, crafted symbolic objects, controlled fire, made complex tools, and interbred with Homo sapiens. Yet one assumption remained largely untouched: their extinction timeline. The prevailing model places Neanderthal disappearance between 41,000 and 39,000 years ago, coinciding with the expansion of modern humans into Europe. Climate stress, competition, disease, and assimilation were all proposed as causes. But these models rely heavily on indirect evidence. Tool cultures, charcoal layers, and fragmentary remains often dated decades ago, using methods far less precise than those available today. The question was never whether Neanderthals disappeared. It was when and how cleanly that disappearance occurred. The first cracks in the timeline appeared quietly. In southern Iberia, sites such as Gorham's Cave in Gibraltar produced Mousterian tools, traditionally associated with Neanderthals, dating thousands of years later than expected. Similar anomalies emerged in the Balkans, the Caucasus, and parts of southern Italy. At the time, many researchers dismissed these findings as contamination or cultural persistence without biological continuity. Stone tools, after all, do not prove who made them. What changed was bone. In 2022, a consortium of European paleoanthropologists began reanalyzing human skeletal remains, recovered decades earlier from marginal sites, caves and rock shelters that had never fit neatly into established chronologies. Many of these bones were poorly preserved, incomplete, or stored in museum collections without modern testing. Using ultrafiltration, radiocarbon dating, collagen fingerprinting, ZooMS, and uranium series corrections, the team sought to answer a simple question: were these bones really as old as we thought, or not old enough? One specimen would become central to the debate. Recovered from a collapsed cave chamber in the Dinaric Alps, the partial skeleton, catalogued as DA 1947, had been excavated in the 1950s and loosely dated to the Upper Paleolithic. At the time, its thick brow ridge, robust limb bones, and distinctive inner ear structure led researchers to tentatively classify it as Neanderthal-like, but the specimen remained controversial. Earlier radiocarbon tests failed due to contamination. New methods changed that. They drilled into the femur and extracted a gram of bone powder. The sample was dissolved in acid to isolate collagen, the protein framework that can survive when everything else decays. From that collagen, they isolated individual amino acids. Each one has a timestamp written in carbon. The result stunned even the most cautious researchers. Approximately 10,200 years before present. Independent laboratories in France and Japan analyzed separate samples from the same bone using blind testing protocols. The results clustered tightly between 10,100 and 10,300 years ago. Stratigraphic reassessment of the cave sediments confirmed the context had not been disturbed by later burials or animal activity. But age alone was not enough. The next question was identity. High-resolution CT scans revealed internal bone architecture, consistent with Neanderthals, not modern humans. The femoral cross-section showed patterns of torsional stress linked to high mobility and cold-adapted physiology. The inner ear's semicircular canals fell within Neanderthal variation, outside the range of early Holocene Homo sapiens. Most striking was the dental enamel. Microscopic growth lines revealed developmental timing, characteristic of Neanderthals: faster childhood maturation, thicker enamel, and a pattern of stress markers unlike those seen in contemporaneous human populations. This was not a modern human with archaic traits. It was something else. The implications were immediate and explosive. If Neanderthals survived until 10,000 years ago, they overlapped not just with early farmers, but with societies already experimenting with permanent settlements, ritual architecture, and animal domestication. This was the world of Göbekli Tepe, Jericho, and the first agricultural transitions. The idea that Neanderthals lingered into this period challenges every clean boundary we draw between archaic and modern. Predictably, skepticism followed. Critics pointed to the absence of clear Neanderthal settlements from this time period. Others argued that isolated skeletal traits could represent a deeply divergent Homo sapiens population rather than true Neanderthals. Genetic confirmation, the gold standard, was unlikely. DNA preservation at 10,000 years in temperate climates is notoriously poor. The research team did not deny these limitations. Instead, they widened the scope. Reanalysis expanded to additional specimens. In the Caucasus, a fragmentary jawbone recovered from Mezmaiskaya cave, previously dated broadly to the late Paleolithic, was re-examined. New dating placed it around 11,500 years ago. Morphometric analysis showed a retreating chin, thick mandibular body, and dental arcade shape more consistent with Neanderthals than modern humans. In southern Italy, a partial cranium from Grotta del Cavallo, long debated due to conflicting dates, was reassessed using Bayesian modeling that integrated stratigraphy, associated fauna, and updated radiocarbon calibration curves. The revised estimate narrowed to just under 12,000 years. Each specimen on its own was ambiguous. Together, they formed a pattern. The emerging model does not suggest thriving Neanderthal societies roaming Europe in the early Holocene. Instead, it points to relict populations, small, isolated groups surviving in ecological refugia long after their numbers had collapsed elsewhere. Mountainous regions, karst landscapes, and coastal enclaves offered stable microclimates and limited competition. These groups may have had minimal contact with expanding Homo sapiens populations, leaving little archaeological footprint. Their material culture may have been simple, ephemeral, or archaeologically invisible. In this model, Neanderthals did not vanish in a single extinction pulse. They faded unevenly, leaving biological echoes long after cultural dominance had passed. This interpretation aligns with patterns seen in other species, from island dwarf elephants to relict hominin populations like Homo floresiensis. Extinction, it turns out, is rarely tidy. Still, the burden of proof remains high. No intact Neanderthal genome has yet been recovered from Holocene layers. No unequivocal Neanderthal settlement has been identified from this period. And extraordinary claims demand extraordinary evidence. The authors of the skeletal analysis acknowledge this openly. They do not claim the case is closed, they claim it is open. What the new data demonstrates, conservatively, is that the last appearance date of Neanderthals may be wrong by tens of thousands of years, distorted by methodological limits and assumptions baked into earlier research. As dating techniques improve, old bones are speaking again. The broader implications extend beyond Neanderthals. If multiple human lineages overlapped longer than assumed, the emergence of modern humanity becomes less of a clean transition and more of a mosaic. Cultural innovation, genetic exchange, and extinction may have occurred side by side, unevenly across regions. It forces a re-examination of what it meant to be human in the deep past, and how much diversity once existed within our genus. We may not be the survivors of a simple victory. We may be the inheritors of a crowded world. For now, the bones remain fragments. The evidence is compelling but incomplete. Additional finds, improved DNA recovery, and transparent replication will determine whether this hypothesis reshapes textbooks or joins the long list of scientific maybes. But history has taught us this much. Whenever we declare the past settled, it has a habit of proving us wrong. Neanderthals were never as simple as we imagined, and they may not have left us when we thought they did. The boundary between extinction and survival is thinner than it looks. As science sharpens its tools, that boundary continues to move, not backward, but deeper into the complexity of our origins. The question is no longer whether Neanderthals mattered. It's how long they remained part of the human story, and whether